Over the past 2 years, the pandemic has fast-tracked digital transformation. Many have found it hard to keep up. Samsung Foundry, however, isn't just any business. We use this opportunity to break new ground. We set new goals to add one more dimension to what we offer. To help our customers adapt and succeed, we focused on adding new dimensions to our services. Samsung Foundry successfully developed the world's first 3nm process. Featuring the cutting-edge GAA technology, the solution will be key to creating more compact chips. In addition to developing the groundbreaking X-Cube solution, to meet growing global demands, we expanded our capabilities even further. Samsung opened the world's largest semiconductor factory in Pyeongtaek. The V1 line in Hwaseong, a facility dedicated to the EUV process, also began production. Through it all, we faced every challenge with only one thing in mind: our customers. We can't wait to show you what we've been working on. Are you ready to see our accomplishments?
Good morning. My name is Siyoung Choi. I'm honored to join you today at the 2021 Samsung Foundry Forum. Last year, we made a difficult decision not to host this event. I can't tell you how great it feels to be back and sharing these exciting updates with you. Before I begin, I'd just like to say thank you to everyone who has been working tirelessly during the pandemic. Your efforts are greatly appreciated, and I hope you all continue to stay safe and healthy. The event of the last 2 years have been unprecedented for all of us. For those of us in the industry, COVID-19 has made the already competitive market even more volatile. Suddenly, the world is facing semiconductor shortages. And with the demand for flameless ICs expanding beyond PCs, servers, and mobile devices, the market is entering the era of uncertainties. It's not yet clear how long this era will last. We do expect, however, that few companies will be equipped to compete in these new frontiers for process scaling. Samsung Foundry has been preparing for this rapidly changing landscape. We have done so by advancing our 3 main areas of focus: process technology, manufacturing operations, and foundry service. Since launching as an independent business in 2017, our company has established a stable foundation for growth by building new fabrication lines and developing more cutting-edge processes each and every year. Now we are ready to add a whole new dimension to these key aspects of our business. Doing so will help us maintain our edge in the fiercely competitive market. We will continue to innovate with technologies like SFF in advanced nodes, while unlocking diverse applications for legacy nodes as well. We will improve the efficiency of our existing fabs, and we will take steps to launch new ones as soon as possible. And we won't stop there. We will also continue to enhance our foundry services by catering to clients' needs in the mobile, automotive, and high-performance computing sectors. As we embark on this journey of growth, I am grateful to be able to follow in the footsteps of leaders as hardworking and dedicated as my predecessors, E.S. Chung. It's an honor to take on this role at such a pivotal time, a time when Samsung Foundry is in the midst of a momentous transformation. More on that in just a moment. Our company's goal has always been to become what's known as a pure-play foundry. Over the years, we have made progress on that goal with advancements like the first EUV-based 7 nano process, 5 nano mass production, and the 3 nano GAA process. Now, our commitment to innovation has driven us to expand in exciting new ways. Recently, we announced a large-scale, multi-billion-dollar investment. Building on that, we will increase our overall production capacity while developing more innovative legacy, specialty, and advanced processes. Back in 2015, Samsung Foundry began mass producing mobile AP products built on the legendary 14 nano process. Now we are working on developing a low-cost process that could unlock more uses for this legendary technology. Our pursuit of innovation has also led us to develop unique capabilities. Take the 10 and 8 nano processes, for example. For Samsung, the particular nodes have become a specialization of thought, ones that cannot be found at other foundries. This EUV-less processes combines solid performance with the clear cost benefits of 7 nano. And because Samsung has been mass producing 10 and 8 nano for several years, the production process itself is especially stable. We expect demand for 14 nano rigorous processes to carry over to 8 nano. We are preparing for that future by developing what referred to as an 8 nano RF process. I will get back to that technology in just a second. The 5 and 4 nano processes, meanwhile, in the most advanced FinFET process in the industry today. So far, its applications have mainly been focused on mobile devices. As we look toward the future, we are developing processes that will support a variety of uses. This will include both high-speed and extreme low-power applications. We are also actively developing a 5 nano process for automotive users. 3 and 2 nano represent the future of process node technology. The former is the first process node to feature the new gate-all-around or GAA transistor structure. We dubbed it as a multi-bridge channel field effect transistor or MBC-FET for short. We have demonstrated GAA's superiorities over FinFET at Samsung Foundry Forum and at major conferences around the world. Now we are starting to see foundries make the switch to the GAA. We expect the mass production of GAA products to begin soon in the first half of 2022. 2 nano is expected to begin mass production in the second half of 2025. When it does, it will represent the third generation of GAA applied process technologies. Ultimately, we expect the industry's transition to 2 nano to be smooth, thanks to the previous experience with 3 nano. In preparation for that future, Samsung Foundry will continue to strengthen its competencies in process technologies. But we must also keep in mind that different clients have different needs. For example, scaling may not be the perfect solution for everyone. That's why we are preparing to take a silicon scaling a step further. We'll do so by examining how heterogeneous integration can help enhance performance and reduce sky-high R&D and chip cost. We are also keeping watchful eyes on industry trends. Recent trends in specialty process technologies suggest that major changes may be on the way. This comes as manufacturers consider transitioning specialty processes from the 28 nano product process to the 14 nano FinFET process. While processes like CIS, DDI, and the EMLAM have long remained in 28 nano, 14 nano FinFET offers key price, performance, and power benefits. Samsung Foundry has started developing a 17 nano process that combines 14 nano front end of line with a 28 nano back-end of line. This opens the door for more cost-effective CIS logic and high-voltage mobile DDI. We are also applying fresh-type eMRAM to the 14 nano FinFET process. This allows us to increase read speed as well as power and density. Now back to the process technology that I mentioned earlier, RF. Right now, radio frequency technology is steadily shifting from 14 to 8 nano. With the emergence of 5G, RF technology has become an even more critical aspect of foundry's offering. However, unlike logic technology, RF is not always suitable for geometric device scaling. To address this, Samsung has made it its mission to enhance RF technology to allow for seamless heterogeneous integration with logic. Soon, our company will introduce even more innovations that support top-notch RF applications for 8 nano and beyond. At Samsung Foundry, we strive for excellence in all aspects of manufacturing and operations. Since 2019, we have devoted a great deal of effort toward becoming the first to bring EUV to mass production. Our experience in this area has allowed us to reduce the amount of time required to increase yield and capacity. These are two very important aspects of foundry process. It has also made it easier to reduce production ramping up times by synchronizing our existing fab systems with the manpower. Meanwhile, we are already seeing stable yields of big die chips for high-performance computing. And our 8 nano process has achieved the world's fastest turnaround time and D0. Our network of foundry has also been steadily growing. Samsung Foundry currently operates fabs in 4 locations: Siyoung, Hwaseong, and Pyeongtaek in Korea, and Austin, Texas in the United States. All 3 Korean fabs are located close to one another, which allows them to share infrastructure and maximize the synergy. We are planning to add additional space to our new Pyeongtaek-based fab. It will be used to produce process technologies 4 nano and below, and it will enable us to produce steady supply of 3 nano GAA products. In the US, Samsung Foundry has a long history of outstanding performance. We have been producing steady, satisfying results in this market for 25 years. This has helped pave the way for the construction of future fabs in the US. Many of you may be wondering about our plan to launch a new fab in the US. While I cannot share any detail right now, I can tell you that several locations are being considered. We look forward to making official announcements in the near future. As applications for them diversify, demand for legacy nodes continue to grow. This has led us to consider several options to create a new site for producing legacy nodes. More details on those plans will be coming soon. Now, I'd like to take a moment to discuss something that we at Samsung Foundry view as vital to the future: platform solutions. In addition to developing competitive process technologies and foundational IPs, we identify technology that are essential for producing competitive products, and we incorporate those technologies into various product platforms. Samsung Foundry prioritizes 3 product platforms in particular: high-performance computing and AI, mobile and IoT, and automotive. We offer total product solutions for each one, empowering customers to build competitive technologies and release them more quickly. For HPC and AI, we offer large die design methodology. We also offer 2.5D and 3D integration solutions and high-performance IPs such as DRAM Pi and SerDes. For mobile and IoT, we offer low-power design methodology and IPs, safety and connectivity IPs, and embedded MLAN. And for automotive, we have prepared safety and security solutions to meet both ISO 26262 and AEC Q100 certifications. At the same time, we are continuously improving the quality of our design services. Doing so helps our customers optimize designs and turn their big ideas into chips. We at Samsung Foundry know a thing or two about big ideas. After all, we have made a name for ourselves based on the idea of combining outstanding technology, operations, and the service. Our commitment to those ideas has primed our business for growth. In order to continue growing, it's important that we listen to our customers and consider collaborations that will offer them more value. Collaboration with a company like IBM. The explosive growth of AI and machine learning has sparked more collaboration in high-performance computing than in any other application. For years, IBM has been defining the future of computing technology. This includes collaborating with Samsung on everything from process development to high-performance server chips. To tell you more about that, here are Dr. Dario Gil, Senior Vice President and Director of IBM Research, Dr. Mukesh Kher, Vice President of IBM Hybrid Cloud Research, and Jamie Thomas, General Manager for Strategy and Development, IBM System. It was a pleasure to connect with you through today's event. But don't go anywhere just yet, because we have a lineup of an interesting series of tech sessions that we know you won't want to miss. Thank you.